Hello geniuses. First of all, thank you so much for your positive response on this poll. In this video, I will share all the interesting part of my M.Sc final project, which was on black holes. So let's begin. So I just completed my masters in physics, and in the last semester we get to do a project which simply gives us a little taste on what a PhD is actually like. So I also did a really interesting one on black holes in the branch of cosmology. Now you know why I give away telescopes. Now the main aim of this video is not to teach you about what I did as my M.Sc project. It is to answer a really common question which comes into everyone's mind whenever we study math and physics. It is where we will use all this. Okay, so we will learn how simple math and simple physics helps us extract so much of information that helps us understand how this universe works. Also in this video, I won't go in much technical details of the project. I want everyone to understand it, so I will just share the fun and interesting part. Even though if you do not understand what I am saying, don't worry, just listen to it. It's pretty fun and you will learn a lot. Okay, so now let's start from the basics. Most of the galaxies at their center have a black hole. Now what is a black hole? In simple words, a black hole is a body which somehow got so massive that its gravity is so strong that even light cannot escape it. That's why the name black. Now there is a class of black hole known as quasars. Now quasars are a type of black holes which are eating a lot of matter. And like when matter goes into that black hole, it doesn't go in a straight line. It circles around it, and while circling around it, it releases a lot of light. Like black hole doesn't release light, but the matter going inside it releases a lot of light. This is known as accretion. In this universe, this is basically the most efficient way to convert matter into energy, but I'm not going to talk about it much. So simply understand there are quasars which emit a lot of light. Like the black hole is not emitting the light, but the matter accreting into it releases a lot of light. Some of the quasars are so luminous, like so bright, that they outshines their host galaxy too. Like the brightness of the whole galaxy is less compared to the brightness of that quasar. Okay, now second thing, you need to understand what is a spectrum. See, in astronomy, whenever we are looking at something and we want to extract some information about it, we look at its spectrum. It is like the fingerprint of that body. We just simply take the light coming from it and separate it into different wavelengths and see which wavelength is high, which wavelength is low, where the peak occurs, and understand a lot about it. Because like for example, there could be some metals there that release specific wavelength, and we know like this wavelength is here, that means this metal should be there in that star. So in simple words, the spectrum is simply the fingerprint of that body, which tells us a lot about that. Okay, now here comes the interesting part. When we were analyzing these quasars, there were two types of different spectrums that we are getting. One spectrum was in which there was a broad peak, a big broad peak. That means we are getting a lot of light in a specific region. And there were others in which this broad peak was missing. There was a very fine peak in place of that. So this was really confusing. Like black holes are black holes, there should not be different spectrums. They are the same thing, so they should emit same spectrum, right? So this was really confusing to astronomers. So to answer this, astronomers came up with a theory. They said around a black hole, very close to it, there is a dense dusty torus type thing. Okay, so whenever that dusty torus is like this, like the dusty torus is like this, and black hole is in the center, so we get a lot of light. Okay, a lot of light, and due to that we get a broad peak. And when the dusty torus is like this, the dusty torus is here and the black hole is in the center of it, then we do not get a lot of light and we do not see that broad peak. So this simply answered why we were getting two different kinds of spectrum for the same thing. So now let's come to the project which I did. The project was simply to reproduce a research paper which was published before, which simply proves the existence of this dusty torus around the black hole using an effect known as the proximity effect. Now you might be thinking, just the reproduction of a research paper? Trust me, if I was the one who did all this, then I would already be a PhD. So reproducing that research paper was itself a really challenging task. Now let me ask you a question. What do you understand by proximity? Like, this word also comes when we talk about phone sensors. There is something that we call the proximity sensor. It is the sensor that is at work when we pick up a call, like we are picking up a call, and when we put the phone near our ear, the screen turns off. So simply there is a sensor here which can detect whenever something is near to it. So proximity is simply the effect of something being near. Okay, so proximity is that. So using that effect, we will prove that in fact there is a dusty torus around a quasar. Now let us understand a type of spectrum that is known as the Lyman alpha forest. You know what is spectrum? Now let's try to understand what is Lyman alpha forest. See, the quasars that we are observing here are so far away, like so far away you can't even imagine that when the light started from those quasars, like started their journey, our solar system was not even here. So old. Our universe was half of its size. Okay, so that far we are looking. Okay, so when light starts its journey from there, and the space between galaxies is really empty, like there is no matter in it, very few amounts of hydrogen atoms you can find here and there. Okay, so imagine there is a light which contains all the frequencies and wavelengths. There is a bundle of photons coming from a long distance into space. Okay, now there is a hydrogen atom which it found, like sometimes it finds that, and the hydrogen atom absorbs at a specific wavelength. Like every atom absorbs at a specific wavelength. That is how we tell from the spectrum, like these are the elements there in that star. So the hydrogen absorbed at a specific wavelength, and at that specific wavelength in the spectrum we will get a dip, a fine dip like this. Okay, now as the light is going, what happens is this. See, this is really interesting and I don't know if you will understand it or not. The space is simply expanding. This is a really famous theory. So what happens is this, that see, it absorbed at a specific wavelength, and as light is traveling hundreds of light years, the space expanded, and due to that expansion the wavelength got stretched. Okay, and the wavelength got stretched, so that dip that we had at a specific frequency shifted. Okay, and as it shifted to back, another hydrogen came into the path of light and absorbed at that specific wavelength. Now that wavelength will also shift as it goes, and there is a dips and dips that we see into the spectrum. I hope you have understood it, but if you didn't understood it, just understand, in the spectrum of very far away objects we see a forest of lines like this. Okay, now what happens near a quasar? Quasar is really luminous, emits a lot of light. What happens is that the hydrogen near that quasar gets ionized, like the electron gets separated from the proton. Now it cannot absorb wavelength. So what happens is that this dips that we have decreases near the quasar. So because of the quasar that is near, these dips that we are seeing decreases. So this is known as the proximity effect of quasars. Okay, so in a nutshell, there is something that we call the Lyman alpha forest, which is a spectrum of very far away objects which have dips like this. Near a quasar, these dips decreases. So because of the quasar is near, there is an effect in the spectrum. This is known as the proximity effect. Now here comes the result and the interesting part. See, what we did is this. See, there is a black hole here. We analyzed the spectrum in two different regions, in its front and in its above. I won't tell you how we did it because it was really complex. A lot of Python coding went into it. So simply what we got is this. See, we analyzed this region and we got proximity effect. That means there is radiation coming from the quasar. And in this region we did not got proximity effect, like radiation was not coming or it was blocked by something. Okay, so what we got is this. In one side of quasar there is a lot of radiation which is giving rise to proximity effect. But in one side of it, there is no proximity effect. That means there is no radiation. Now there are two conclusions. One conclusion is that the quasar emits in one direction and it does not emit radiation in another direction. Like it is like a torch, not a light bulb. That is pretty weird and it should not be like this. So the another conclusion is that there is something that stops that radiation coming from one direction, and most probably that could be the dusty torus. So from the proximity effect, we got to know that there is a dusty torus around the quasar. So this is how we simply prove that there is in fact a dusty torus around the quasar, and my project was simply this. I made a presentation on this and its link is in the description of this video. You can look at that presentation too if you want to know the technical details on how we exactly did it, because I skipped to explain a lot of things while making this video because I want everyone to understand the interesting part of this project. Also, one thing that I want to tell you, what if we are wrong? Like there is no dusty torus around the quasar and there is something else that we don't know. Like no one has ever seen that dusty torus. No one have ever went to a black hole and seen like, oh, there is a dusty torus. No. So what if we are wrong? Would I be sad, or the scientists that said there is a dusty torus are sad? No. Like I think that scientists are the only people in this world who get excited when they are wrong. Like we will discover something new whenever we are wrong. Now if you have not understood anything in this video, don't worry, just understand this. See, no one has ever seen a black hole till now from their eyes, okay? And the things that I talked about in this video, the data of the stuff that I took for this project were so far away, like we can't even imagine. Even though from our knowledge of math and physics, we are able to extract so much information about them. So this is the power of what we learn on those books, and we say like, oh, what is its use? It has enormous uses. With so less information, so less at our hand, just by looking at the spectrum, we are able to say that there is a dusty torus there. And if this doesn't amaze you, I do not know what will. Just one thing that I want to tell you is that in this project, I used Pythagoras theorem. Okay, so see, that is a basic theorem that we learn in like 8th or 10th class. But that theorem is used to understand one of the most weird and interesting objects in our universe. So always keep that in mind. Whatever you are studying in math and physics have applications. So I hope you found this video interesting. I'm extremely sorry if I was not able to explain some point in a more easier way to you, and thanks for watching this video, and always remember that math is everything.